My name's Sean Finn. I'm one of the owners of F3 & Associates. And this was working a second ago. Okay. So today, this is what we're going to talk about a little bit. Perspective on the acceptance and advancement of reality capture in the petrochemical industry and the similarities of that industry with the BIM industry. What's important is it's kind of my perspective. It's what we've gone through working in oil and gas and what we've gone through working in the BIM industry when we combine scanning with 3D CAD and other services. So at the end of the class, hopefully, we'll learn a little bit about reality capture challenges in the oil and gas industry, reality capture challenges in the BIM industry, and learn more from the similarities of the two, including market acceptance and market growth. So I always start out with safety. We work in a lot of dangerous places, so usually one of my first slides is always a safety slide. So does anyone have a two-story house? Yeah. So I always have my kids count the stairs. They always know how many stairs there are in our house in case there's an emergency. We live up in Northern California, so we get a lot of quakes. And if the power goes out and you know how many stairs there are, you won't trip when you're leaving if the lights won't come on at night. So that's my safety topic. And I stole it from Joel at Leica, so I always put a little footnote in there in case he's sitting in the audience. So a little bit about, again, the format of the lecture today. We're a surveying company, so we'll talk a little about surveying, 3D scanning, oil and gas solutions, BIM, and then at the end I'll talk a little bit about augmented reality. So first, a little bit about F3. We were founded in 2004 as an industrial surveying and 3D scanning company. Today, we're a global provider of land surveying, 3D scanning, 3D printing, metrology, BIM and CAD services, and we're fortunate enough to work with a lot of great companies. I got my mom calling. I think I'll have her wait. You guys want me to answer it? No. What, Mom? So 3D scanning in oil and gas. So the origins, roughly, I'm going to go over that. The struggles, at least ours, with acceptance and accuracy, adaptation, successes, and then kind of the same thing with BIM. It's crazy how they parallel each other a little bit, at least, again, from our perspective. Then we'll have some time for questions. Does anyone know where that picture is? There's a prize. That's all right, because there's no prize anyway. It's the Bay Bridge. So, it's my theory that the BIM industry, at least in Northern California, is on the same pace as the petrochemical industry was about 15 or 20 years ago. And what I mean by that is the petrochemical industry was slow to catch on. Started off using 3D scanning, reality capture, and offshore oil rigs. It's kind of where the techniques were perfected. And then went to refineries, tankers, terminals, and pipelines. You know, the BIM industries was slow to accept point cloud technology as well. I think that a lot of it was the architects didn't know it existed years ago, and then when they did know it existed, the price point was still high because most of the service providers that were really good at 3D scanning were working in this petrochemical industry, and you have high labor rates and safety and all these things, so you know the price years ago for point cloud data collection was extremely high. Contractors started catching on to it, started using it. In our experience, maybe 4 or 5 years ago, started becoming things that we would see it on bid documents, laser scanning. When Revit 2012 came out, it kind of changed things a bit because then point cloud technology was able to go right into the Revit platform, somewhere between 12 and 13. And that started changing things. And then we started seeing more architects requesting point cloud collection for tenant improvement projects. And then we started seeing AutoCAD deliverables. I'll talk more about that. I'll talk a lot about that, actually. What I mean by that is point clouds that we actually turn into a 3D CAD environment so that you're not handing over a point cloud per se, you're handing over a 3D CAD that has been essentially constructed from that point cloud data. And petrochemical is still catching on. Even though this is kind of where the industry was born, there's still refineries that we work with that have no clue about the technology, and there's an education process that they still go through. So, and I think that for BIM, it's on an unreal growth pattern. What we're seeing now, I mean, you just walk through the halls of this conference every year, I just get more and more amazed at how many service providers there are, how fast this technology is really growing. It's unreal. All right, so scanning. Cyra Technologies, along with my friend Jerry Dimsdale, invented the first mobile scanner, if you ask Jerry anyway. Ben had to own Cyra Technologies. Jerry was a doctor out of University or Berkeley, and they thought this technology would be the future. And so the story goes something where Ben asked Jerry to, Jerry was retired, to come over and help him develop this 3D scanner in the Bay Area, and asked him how long it was going to take and how much it was going to cost. And he says, I don't know and I don't know. So he's like, all right, well, I'm going to give you 1 month and I think $100,000. And so 3 years and $3 million later, they had developed the first scanner that you see up there. Does this have a laser pointer on it? I'm sure it does. Yeah, right there. And that was the first mobile scanner. It was really huge when they first came out with it. And Chevron said to them, when they caught wind of this, said, if you guys can make this portable, and that was the one that they actually made portable, we'll buy it off you. So the first one they sold was to Chevron, and Chevron used it on oil derricks. And the technology was really big, really clunky, hard to move, very slow, but it worked. And it was able to capture environments on the oil derricks and bring that data back on shore and do turnarounds and replace in kinds. And if there's ever an application, it's going to be an oil derrick where you have, very little space and you can't get it wrong because everything has to be manufactured offshore. So that technology then grew into refineries and then construction sites. And then Leica ended up acquiring the patent for the Cyrex scanner. And if you go down and you see these P20s and C10s, that's basically the latest generation of that same technology that Jerry developed in Berkeley. So anyway, that's a little brief history as far as I know on how scanning came to be. And so we as a service provider, we really struggled with even getting local refineries and industrial places to accept this technology because we were trying to hand them a point cloud. And this is years ago for us. And it wasn't until we decided that when you actually do something with the data, this business will actually grow. So we were forcing point clouds into our clients' hands, and they couldn't accept it because they didn't have the software, they didn't have the computer space. It was frustrating. So we started going back to our roots as land surveyors and producing maps from the point cloud data. And at the time, we would do a map like you see here, and we would just put this in a little block on the title page just to say, by the way, it's a 3D CAD model too. But even then, people weren't using a lot of 3D CAD. But this actually started selling the service by doing something with the point cloud data and not trying to force point cloud data into our clients' hands. So early successes. We had to kind of build on proof of concept. It was a big education process. And this is in the petrochemical industry as well as in the BIM and construction industry. It's the same thing that we're going through now that we went through years ago. One of the examples that we used to take on the road with us is this one. This is a dry duct tower replacement. It's replaced in kind. The challenge is the unit doesn't want to be shut down. Scaffolding is expensive and dangerous. There were no record drawings, and the manufacturer needs direction. So that's basically the job right there. We had to replace this pipe. And the client still had no clue how we were going to achieve this as-built. And they didn't care because at the end of the day, we just extracted what we needed and we gave them this set of drawings. Again, the point cloud never really went to the client, it stayed in our office. But we were making these drawings, and essentially that's the end product. The client never saw the cloud. This is the same in BIM when it first started as well, and I'll talk about that. For us, the perfect service is that when this pipe's manufactured, we'd like to go to the manufacturer's facility and also scan the one they built. And if we can do that, then we kind of close the loop on where the error can be, and the thing usually slips right into place. This particular pipe was built in Italy, and the client would not fly me to Italy to scan that pipe, no matter how much I asked and begged and pleaded. But when it got on site, we discovered that it was actually built to a 52-inch opposed to a 56-inch diameter. We were able to make that change in the laydown yard before they flew the pipe up. So, as jobs like that got behind us, we started discovering that clients were getting more and more confident with the process, and they were trusting in the data, and they were trusting in the accuracy. So as this confidence increased with our petrochemical clients, we started seeing the submittals start changing. And now what we're starting to see at this time, this is a couple years ago, is the introduction of a 3D CAD model as the submittal. So where we were just giving them plans in the past, now we're starting to give them 3D CAD models. So something like this turns into something like this, and that's the end result. Maintain the accuracy of the point cloud, which is about 1/8 of an inch. And this is a working, living, breathing model. We use the combination of AutoCAD Civil 3D and AutoCAD Plant when we do these models. Valves actually turn. It can be the basis for asset management, depending on how savvy the client is. Another example is this pipeway here. I like to use this slide too because it illustrates, I don't know how familiar everyone is with scanning, but scans come together from multiple setups, and that's how you create one true 3D scan world. If I was to turn a scanner on in the middle of this room, I'd capture the side of your heads and the front of the chairs, but I wouldn't capture the back. So we move the scanners around and we stitch them together with targeting. If you practice surveying like my company does, then you can stitch them together with coordinate geometry as well. And typically, if you are very careful with this technology, your bundle adjustment, no matter how many scans you throw in the mix, can be 1/8 of an inch or better. And so multiple setups are used to achieve one final cloud, which achieves one final pipeway. Another example of that. We don't submit a lot of Revit data in the petrochemical industry. Most of it's 3D CAD. Some more examples. So, probably the biggest reality capture milestone for us, and this is the one I like to talk about quite a bit, is this project. This is a major turnaround of a coker unit. All internal components need to be replaced. The owner wanted to remove the top of the coker. The coker is 400 feet tall. And the owner wanted to cut the thing in half, and the owner being the refinery, set it on the ground, and then that's how they're going to remove the internals. Well, the contractor thought it would be good if they could just cut 2 door sheets in this thing instead. Cut one on the bottom and one at the top, and they could remove the internals, and it would speed up the process. It would be safer. It would be more cost effective. But the owner didn't believe it was even plausible to do the project this way. So we scanned it, as you see up top, and we produced this 3D CAD model of the outside and the inside. We got to the inside through a couple of manways, and then we filled in the gaps with what we couldn't see with the archive plans in a 3D CAD environment. And the result was, it's going to be a long day with this clicker. There it is. So the result was this coker here, again, 400 feet tall. All the internals are on the inside where they're supposed to be. All the different colors signify where the contractor wanted to slice this thing up to remove it out of the door sheet. And the reason we produced this was to make this removal video right here. And this removal video is what gave the owner the confidence to let the contractor proceed with the project in this direction. But it was the same thing. It was having them trust in the data, having them trust in the workflow, having them trust in the contractor's plan. Everything was to scale, and when we produced this video, it gave a visual concept of what the contractor was trying to achieve, and it gave them the green light. And because it's all based off of scan data, if it works here, it's going to work in real life. We see a lot of similarities to this when it comes to, you know, when I think of BIM, I don't just think of buildings. I think of also your contractors, such as your, you know, your Kiewits and stuff that are building great infrastructure and utilizing models just like this to do proof of concepts, to actively perform the job before you perform the job. The project didn't go as fast as this video. This is riveting television here. So that's all the refractory. And the big challenge was this yellow thing there. That was the deal breaker for them, and that was I actually had music playing, the Space Odyssey, when I had this video originally, and it worked well. Wow. And there's the top door sheet. So while this video was instrumental in getting them the green light to proceed with the project in this way, it still was not all that we needed for a communication tool. So we produced this 3D print. Now I'll be talking more about this at 3 o'clock. This is the only example I'm using here. But my company has several patents when it comes to scanning and augmented reality and scanning and 3D printing. And this 3D print, we printed out 5 of these things. In the back of it, it opens up like a dollhouse, and we've hidden magnets inside the print so that everything disconnects the same way the contractor wanted it to. We printed out little guys so they could stage construction, little hard hats, so they would be safe. And we printed out 5 of these things, and it became the communication tool. The ironworkers got them with the pipe fitters, the engineering team, the owner, everybody had one of these prints, and they always talked about the project before they started the day, and it was a very valuable tool. This is another example that I like to talk about. This was an extreme value to the client. We also made a 3D print for this one as well. I don't have an example of it here, but this is a separator, and it's taking new design, right, with an existing facility, same as BIM. So we scan the one that is in the refinery. We take the plans from the engineer, and we make one model. And we discovered some things on this thing that picked up 2 days on the schedule for the client. For this separator to be shut down was $500,000 a day. So we picked up 2 days on the schedule with about, you know, very minimal cost to the client. So at this point, the refineries are getting sold on this technology. And the last industrial example I like to talk about is this one here. This is an aqueduct thing, and this project is a lot like your typical BIM environment. We scanned this shaft. We put the scanner, we zigzagged all the way down. We use metrology equipment at the bottom to increase the accuracy of it. Metrology is usually used in aerospace. And we took the engineer's design for all the internals of this thing, and we slid it into place with a 3D CAD model, and we discovered it didn't fit. So we sent them the model with all the internals, and they modified the design, and when the thing went to construction, it slipped right in. So it's having this forward planning. So we went from really selling the clients on these concepts that it was even valuable to them, to now they can't live without it, and that's through successes. And I think the BIM industry is on the same path. So, come on, there we go. So what has this taught us about BIM? There's similar traits between the petrochemical industry and the BIM industry. They're both slow to accept, they're slow to trust the accuracy of the data, and the submittals are changing. It's evolving very fast. And what I mean by that is, like I talked about at the beginning, with the petrochemical industry, we had trouble giving them what they needed with the data. And then everything evolved. Now we're handing over point clouds to your Jacobs and your Parsons and people like this. The point cloud has now become the finish line because the industry's accepted the technology and it's become a standard. Now you're seeing specifications on how you collect the data and how it's presented. And that took a few years. With the BIM industry and the architects and the contractors, it's the same story. The submittal's changing, acceptance is becoming more and more, and it's a little bit of confidence as well. Is the point cloud really doing what we say it's doing, and is it accurate as we say it is? So, example I like to talk about when we're starting to lead into the BIM part now is this project here. Studies have proven that Cal is the best football team in the world. I don't know if you guys knew that or not. So, project challenges on this one is the Hayward Fault. The stadium is right on the Hayward Fault. That's one of the reasons that we have trouble scoring touchdowns. Concrete poured by hand in the 1920s, and the 50-yard line was not the center of the stadium. This is all things that we discovered through the scanning process. So how this project would go is, you see right now you're on the internal of the stadium in this picture. We would chase the demolition process, and we would scan, and we would produce drawings to the construction team, Webcor, and HNTB, the architect, and they would modify their design in real time. This is a shot of the point cloud. It's just every day we would scan, and we just, through redundancy, we populated this total environment. This is Tightwad Hill. Watched a lot of football games from that hill because I couldn't afford to get in. Again, best football team in the world. So this is what we were producing at that time. Again, Webcor had not worked with point cloud at this point. They had never done a job with a point cloud. Today they own 4 scanners, you know. And this is the first job that they used point cloud with their BIM environment on. But since it was an introduction for them, we had to go back to paper. Just like the petrochemical industry, we would scan, we'd have all this beautiful 3D CAD data that no one wanted, and we produced these PDFs every single morning for the construction team for every phase of the demolition. And we discovered quite a bit. We discovered that the columns were not vertical. They were poured by hand, so where the plans call for them to all be on top of each other, they actually staggered quite a bit. They leaned in and out, which they were expecting, but not as much as they actually do. And then at some point, the 50-yard line was decided that was the center of the actual stadium, the structure itself, when actually the football field was shifted within the stadium about a foot. So none of the doors and none of the windows were going to line up when it came time, because the original survey, performed by others, was off. And we found that correction, and we made that correction, and it's what enabled this project to actually be completed on time, was these things. We ended up scanning the stairs as well. We scanned the stairs for the fire marshal to certify that the stairs were built to code. And the fire marshal was very, very anal about this, and he didn't want our data to be used. He was out there with a jig by hand doing it. So we had to do 2 rows of stairs as a proof of concept to the fire marshal, produce a spreadsheet of the rise over run, and if it varied at all, he wasn't going to accept it, and we matched his measurements. So after that proof of concept, we scanned the entire stairs that the team built, and that became the certification. We got the project done on time, and they went on to an undefeated season. Won the Rose Bowl. And, no, all right. So we should have made the end zones wider, because our quarterback can't find it. You know, no matter which quarterback we have, the other team finds the end zone fine, but. All right, it's enough about that. Floor flatness as well. Now this is something that we did in the press box, but this is something we do quite a bit for contractors in the BIM environments. We'll scan the floor, and we'll produce a color-coded flatness map once the concrete's poured. This is starting to become very commonplace. I think that there's going to be some changes in the way that concrete floors are certified, at least now that the contractors have accepted scanning technology for their BIM environments. The way that they do floor flatness inspections now is pretty primitive, and I think in probably the next year you're going to see floor flatness certifications being done with laser scanners. And what's great about that is you get a lot of bonus data, right? So you're scanning the floors for concrete flatness, but you're also picking up the overhangs and all the pop-throughs and everything else, and it becomes this great use of data. So the industry goes from paper to 3D CAD and Revit. Revit 12 allows for point cloud insertion. This is the same pattern that we saw with the oil and gas industry. As the industry accepts the technology, the submittal changes, and the industry itself grows. So you go from just point cloud data to a 3D CAD model. And that's kind of where we are today, is one of two things is our submittals now are a point cloud to the Revit users that insert it, or a 3D CAD model. So, and obviously clash detection. We all know, all the BIM professionals in here know about clash detection. And that's something that actually in Navisworks is a big use for the BIM data, is taking your existing facility and putting your new design in there and seeing what hits and what misses. And that's something that the petrochemical industry is now utilizing, and so it's kind of like come full circle. Now the petrochemical industry is having us scan stuff and then putting their new design in to do their own clash detection programs. This is at the Walt Disney fireworks thing. I think there's like 7,000 clashes in this thing. I can't remember. So, what I want to talk about now, finish up, and again, as I promised, it's not going to be that long, is augmented reality. A lot of talk about augmented reality these days. There's a lot of people investing in it. We've been practicing augmented reality with some of our submittals for about 2 years now. Where are we here? So, in the past, augmented reality was kind of whimsical. You watch football, the first down marker is not really there, right? It's augmented reality. I like to use this slide because it clearly shows the Oakland Raiders getting smoked by Tennessee. It's like 7-54. How do you score 54 points? And didn't they just lose by 52-0 recently too? I just want to look at that for a while. I'm a Niner fan. So, they're not doing much better. Augmented reality. So we've got a few sets of Google Glass. We talked about this at Hexagon this year, and we're launching these BIM environments that you can visualize when you walk into the construction site. So there's a couple different ways that can happen. It can happen through the gyroscope, accelerometer, and through the GPS on the device. The Google Glass actually has all these things. Same thing as your tablet and your phone. So essentially you could walk in this room and you can orient yourself to the walls, and plus or minus a foot or so you would see either what's behind the walls or the new construction. Well, we've kind of developed some stuff and taken this a little further. And utilizing survey technology, practicing land surveying, we can scan an environment when the construction is taking place, like a hospital, for example. It may not be important to know what's behind these walls, but in a hospital, that's where all your important assets are. So as the hospital is being built and the walls are not skinned up or exposed and the pipes are exposed, we can scan that based off of a land survey. Then they can cover up the walls, and we can go back and we can set QR codes. QR codes are what they're scanning when we walk in, but they can be anything. It can be an Ansel Adams photo. It can be a this is what you should eat in a hospital chart. And when the maintenance guy shines his tablet or his Google Glass at that, it disappears and you're looking at what's behind the wall within about 1/8 of an inch. And that's the difference in when you practice surveying with this technology. The QR codes are actually surveyed in. So this picture, we'd actually put a crosshair of where it goes by rotation and orientation because it has a relationship to the BIM model behind it. These are snapshots we took with the Google Glass. Google Glass I'm not a fan of. It lasts 10 minutes, 15 minutes on the battery, gets hot. They can do much better. So one of the big applications that we've been doing over the years with augmented reality is up in Northern California. We have PG&E as our provider, and the petrochemical industry as well. A lot of their important assets are underground. So we have a pothole once plan to where if you have, potholing is dangerous and expensive. So if their pothole operation is going on, we get mobilized to the site and we set up a survey baseline and we scan it once the pothole operation is complete. And then they cover back up. And then we can set a permanent brass disc like a survey monument in the correct location, and that becomes the QR code forever. And that disc has a relationship between the assets that are underground. So at any point now, the client can go with their iPad or tablet and see what's underground. Same thing again behind wall. And that's another way that the petrochemical industry with all this technology and the BIM industry, I think, are on the same path. I think in the future with these wearables, not Google Glass, but maybe something a little more better, as surveyors, we used to do we do a lot of construction layout. We put stakes in the ground, say this curb goes here, this underground system goes here. I think in the future, the carpenters and the ironworkers will just have these wearables on, and the plans, the BIM environment will be uploaded into that technology, and they'll have a different color for whatever their trade is, and they will be able to see where whatever their building goes for elevation and location within about 1/8 of an inch. I mean, it's not far, the technology's there. We could do it now. It's just industry acceptance and confidence in what they're looking at. And I think that's what we're working on. It's definitely something that we're developing. Also, we've seen a lot of this now as drones. We've done some applications in the petrochemical industry, not for what you may think, but more for air quality monitoring, perimeters. And the BIM industry and the construction industry is catching on to that as well. The guys out there, SkyCatch, have a demo that they do if you go to their booth, where you can see they have these predetermined flight paths where the drone goes up and scans for progress. I think that once the FAA lists the regulations on these bad boys, there's going to be so much that you can do with this stuff, from surveillance to LiDAR to photo inspection to air quality monitoring. I think every construction site is going to have a drone on it. So thanks for coming. Thanks for staying awake. I'll be hanging out